In this lesson, we're going to learn about some exceptions to the octet rule, because most rules in chemistry do have some exceptions. Even the octet rule is not perfect. Now, one exception to the octet rule we've already learned about is hydrogen. We learned a while back that hydrogen is not trying to get 8 valence electrons, rather it's trying to get just 2, and so it's happy with just those 2. And so that's an exception we've already learned about. But here's another one that we can discuss. Boron Tribromide. Now, looking at this structure, it seems like boron should be in the middle. It's our central atom. And then we have 3 bromine atoms. And looking at the valence electrons, we see that bromine over here is in group 17. It's a halogen, so it should have 7 valence electrons. I'm going to put 7 valence electrons for each one of these. There's 7. We have 7 for this one on the left. And 7 down here. And just like we've always done, we always start with the outside atoms and we work our way into the middle. Next we have the boron atom, and boron is in group 13, and so it's going to have 3 valence electrons. I'm going to put 3 for the boron atom. And it looks like all the bromine atoms have 8, but the boron only has 6. And so our inclination might be to move a couple of these, maybe these 2 electrons on the bottom, and bring those up to the top, say right here in the middle, have a double bond. And that looks like it's pretty good because everything has 8 now. But there's a little problem with this. Because if we look at the electron configuration for bromine, remember bromine has 7 valence electrons. It's in period 4, and so its valence electrons would be 4s2, 4p5. And if we look at how they're configured, using Hund's rule here, we'll plot those electrons. 4p5, it looks like there's only 1 electron that is trying to be shared. And so since there's only 1 electron in bromine that's trying to be shared, it doesn't look like bromine can make a double bond. And so this Lewis structure is actually not correct. And so we're going to have to put those 2 electrons back where they came from. So I'm going to put these 2 bromine atoms right back where they were originally, down here. And as it turns out, that's just where they're going to have to stay. Because one exception to the octet rule is that halogens can make only single bonds with a central atom. And so, as it turns out, boron is just going to have 6 valence electrons instead of the octet. And so, if you ever have a case with a halogen, remember that they cannot be double bonded. Now here's another interesting molecule. We have sulfur hexafluoride. Now it seems like sulfur is going to be our central atom once again, so we'll put sulfur in the middle. And then we have 6 fluorine atoms, and they're all attached to that sulfur. And so we're going to have to be very careful in how we draw this. We have 6 fluorine atoms, so we can imagine that maybe 2 of those are in the 3rd dimension. One's coming out of the screen and one is going into the screen. Now the fluorine atom is a halogen, so each of those will need 7 dots. So I'm going to put 7 dots for each of those fluorines. 7 for that one. And be very careful how we plot these. We want it to be as neat as possible. There's 7 for that fluorine. This one has 7 also. Seven for this one. And once again, it's always important to be as neat as possible so we can keep track of where these dots are, where these electrons are. So we have 7 for that one, and 7 for the last one. Now we have sulfur. And so if we look at the sulfur atom, we can see that it is in group 16, so it's going to need 6 electrons. So we'll put 6 there. I'm going to pair them up as well as I can. So there's 1, 2, 3, 4, 5, and 6. And so when I plot this out, it looks like all the fluorines have 8, as they should, but this sulfur atom actually has 12. If I look at those bonds, here's one bond, here's a second shared pair. We have 3, 4, 5, and 6 shared pairs. And so this seems like sulfur is actually breaking the octet rule. But really, if an atom is bonded to more than 4 other atoms, there's not really any other way to do this. And so, you know, those fluorines have an octet, but the sulfur atom is just going to have to live with 12. And so this central atom is going to have what's called an expanded octet. And that's going to happen anytime that there's a central atom bonded to more than 4 other atoms at the same time. So here's another exception to the octet rule. Let's look at one more example. Xenon Tetrafluoride. So we'll put xenon in the middle, and we're going to put the 4 fluorine atoms around it. We know that fluorine is a halogen, so it's going to need 7 valence electrons. So I'll put those 7. That'll be 7 for each of these. And then we have xenon. Xenon is a noble gas. There are a few compounds that can be made with noble gases, not a lot, but xenon is one of those noble gases that can make a few compounds. So xenon is going to have 8. So I need to stick 8 electrons on xenon. So here's 1, 2, 3, 4, and now I've got a little problem because I've run out of room, and I still have to put 5, 6, 7, and 8 on here. And so where do they go? I can't make double bonds because I've just said that halogens can't be double bonded, and fluorine's a halogen. So what do I do? Well, here's what to do. If you run out of room on something like this, put the extra electrons as unshared pairs on the central atom. So that's what I'm going to have to do. The xenon will have to have a couple of unshared pairs. So here's 5, 6, 7, and 8. It's not really cooperating with me here. All right, so there are our last 4 electrons. And so if we look at what's shared and what's unshared here, you can see that we have 4 shared pairs right here. There's 1, 2, 3, and 4. And so the basic structure here, when we draw the electron dot structure, is going to be xenon bonded to these 4 atoms. That's going to have those 2 unshared pairs on the xenon. And so this is another case of having an expanded octet. Xenon, as it turns out, does not have 8. It seems to have 12 total electrons. And the fluorines, of course, all have 8. And so here are a few examples and rules that you can use to tell when the octet rule might not be followed.